Welcome back, my friends. This is Dr. Me with the Actuarial Academy, and today we're going to look at a very common problem in probability and statistics, and will most certainly be tested on your actual exam. We're looking at three random variables, x, y, and z, with respective means of 1, 2, and 3, respective variances of 4, 5, and 9, and pairwise covariances of 2, 3, and 1, as indicated in this statement here. Now we're going to define a new random variable w as 3x plus 2y minus z, and we'd like to find the expected value and variance of w. So again, this is a very common problem, one that you should be able to solve fairly quickly, and if you're going to make a mistake or get a problem wrong in the actual exam, this is one you don't want to make a mistake on or get wrong, because this is pretty straightforward. You just need to know a couple of facts. So the first fact is pretty basic. The expected value, the sum of random variables, is equal to the sum of their respective expected values, regardless of independence or any other type of restrictions. Fact 2 is a little more involved. The variance of the sum of random variables, or the linear combination of random variables, is equal to this quantity here. Now, it almost looks like you're taking the variance operator through by taking the constants and squaring them as appropriately, but there's this extra term, 2ab covariance xy, you have to incorporate. Now, if x and y are independent, then the covariance is 0, so typically we assume x and y are independent, but clearly here there's no indication x and y are independent, so you have to use this formula. And this formula actually holds true for all x and y, regardless of independence or dependence. So both of these are generally true. They are true for all random variables. One source of confusion that typically occurs is, where does this 2 come from? So what I'd like to first do is do a little background here on deriving this formula here before we actually solve this problem here. Just as a little background. I think it's worthy to take a little time. And I'm going to keep it simple. I'm going to just take the variance of x plus y. This is not linked to this problem directly. This is just in general, just taking the variance of x plus y. And so we're going to use our definition of variance, and this is just equal to the expected value of the actual random variable, which is x plus y, and we subtract off its mean. So this is the actual direct definition of variance, no shortcut formula here, and then we square that entire quantity. Now I'm going to use a little algebra here, and not only a little algebra, I want to redefine a few things here. A lot of times in math it's easier to redefine notationally some of these parameters just for ease of exposition. So I'll let the expected value of x equal mu of x and the expected value of y to equal to mu sub y, like that. Now, with this new definition of the expectations of x and y, we can rewrite this as follows. The expected value of, now I'm just going to go ahead and use fact 1 and pass through the expectation operator here and do some rearranging using algebra, employing our new notation. And so this then would be equal to x minus mu sub x plus, now check me on this to make sure that the algebra works out, mu sub y. Okay, now I need a huge brace there, like that, and squared. Okay, that looks a little busy, but it's correct. So now before I write the next step, I want to do a little quick review of algebra. So if you have a binomial a plus b and you square it, we learned from algebra that this is equal to a squared plus b squared plus 2ab. Now if you let x minus mu sub x represent a in this expansion and y minus mu sub y represent b in this expansion, we immediately see that this is just equal to the expected value of x minus mu sub x squared plus y minus mu sub y squared plus 2 times our a times b, which is x minus mu sub x times y minus mu sub y. Now, using fact 1 again, we can pass through the expectation operator, And I think you can convince yourself that once you pass the expectation through, you're going to get the expected value of x minus mu sub x squared, which is nothing but the variance of x, plus the expected value of y minus mu sub y squared, which is the variance of y, plus 2 times the expected value of x minus mu sub x times y minus mu sub y, which is the covariance of xy. So this is equal to precisely what we see in this formula here. Of course, a and b are equal to 1, but this happens to equal to variance of x plus the variance of y plus 2. So now you understand where the 2 comes from. So you always have to make sure you retain the 2 in these equations, covariance of xy, because that is the definition of covariance of xy, the expected value of x minus mu sub x times y minus mu sub y. So that kind of ends our little session there. Now it's just a matter of applying formulas. So let's actually go back to trying to solve our problem. So the problem here is first to find the expected value of w. Now, one thing that was really nice in probability is you just write down what you're looking for and just work out the problem. So the expected value of w, this is actually the easy part, by the way, is the expected value of 3x plus 2y minus z. Now, I guess I didn't really show you in this formula, but the a's, the constants, the a's and b's that you represented here, that are constants, can actually be pulled out front. So this is just 3 times the expected value of x plus 2 times the expected value of y minus the expected value of z. Now we can plug in our data that was given to us. 3 times the expected value of x is 1, plus 2 times the expected value of y is 2, minus the expected value of z is 3. So we're just left with 3 plus 4 minus 3, and 4 is our answer for the expected value of w. Now they also asked for the variance, so in the selection they're going to obviously have many options where the expected value is 4. So that's not enough to pinpoint the answer. You also need to compute the variance. So let me go ahead and skip the page here and rewrite what w is. W is equal to 3x plus 2y minus z. And to compute the variance of w, we just use the formula that we learned on this previous page here. We have to make sure we pass the variance through, pull the constants out front and square them, and then include all the pairwise covariances and make sure we multiply by 2. So the variance of w then would be equal to 3 squared times the variance of x plus 2 squared times the variance of y plus the negative 1 squared, which is just plus 1, times the variance of z. And now we need to include our cross terms. So this is then plus 2 times 3 times 2 times the covariance of xy minus 2 times, now we'll do x and z, and then we'll do y and z, minus 2 times the covariance of yz, which is equal to 9 times the variance of x, which is 4, plus 4 times variance of y, which is 5, plus the variance of z, which is 9, plus 12 times covariance of xy, which is 2, minus 6 times covariance of x and z, which is 3, and then minus 4 times the covariance of y and z, which is just 1. Okay, which is equal to 67. So we've computed the variance of w. So the final answer is, for this problem, the expected value of w, which we already computed, we determined that was 4, and the variance of w is equal to 67. And we're done. Thank you very much.